All right, I want to show you how multiplying two binomials is really the same as multiplying two complex numbers. So over here, we would multiply x times x for x squared, x times negative 3, 2 times x, and then 2 times negative 6. Negative 3 to get negative 6. And then this simplifies to something like this. So I guess what I'm just saying is that, this first, outer, inner, last are a distribution process. So we're going to follow the exact same route. 2 times 1 is 2. 2 times 4i is 8i. Negative 3 times, negative 3i times 1 is negative 3i. And negative 3i times 4i is negative 12i squared. So this simplifies to 2 plus 5i. Now down here, I'm going to do a little simplifying. I get a positive 12. Now again, where did that come from? Well, this guy right here becomes a negative 1, and a negative 1 times a negative 12 is 12. And then the last stage is pretty straightforward. I just group these guys together, 14 plus 5i. It's a nice little system. It feels a lot like this world. Let's just do one more nice and quick one so you can see it. All right, I'm going to go a little faster because it, again, feels a lot like what we're used to. 5 times 3, 5 times negative I. 2i times 3 is 6i. 2i times negative I is negative 2i squared. So that leaves me with 15 plus 1i. And then again, this nice little trick scenario here, this turns into just good old positive 2. And then I get 17 plus 1i, or just 17 plus I would be perfectly fine. Cool stuff. Let's do it again. What I want you to notice here is that this is the way that these are conjugates. They are physically the same except the sign in the middle. Watch what will happen here. This is kind of cool. 9 plus 6i minus 6i minus 4i squared. Now you notice the middle cancels, leaving me with I. And then remember this little trick. Watch this little trick. This turns into plus 4. And so the final answer is just 13. It's pretty cool how it goes from this real complex thing to just one single whole number. Cool stuff.